It started the landing of robotic rovers on Martian soil, such as Spirit, Opportunity, and Curiosity. The data and images of these magnificent rovers have sent back to Earth have piqued our imagination and heightened our determination to go, paving the way for a safe journey and touchdown by humans in the 2030s. Humans are already preparing for this journey by living 250 miles overhead on the International Space Station where there is no gravity. The round trip to Mars could take 500 days or longer. The journey requires the most sophisticated technology ever built, including the new Orion spacecraft and the powerful Space Launch System rocket. When we invent new technologies for space exploration, it benefits all of humanity, contributing to new breakthroughs in medicine, communications, and manufacturing. The journey to Mars will change our history books forever, rewriting what we know about the red planet and expanding humans deeper into the solar system. Follow NASA's journey to Mars at nasa.gov.
Of experts here with us to talk about the Martian and what NASA is doing on Mars right now and how we're getting ready for future exploration. So with us we have Dave Lavery, Chiwetel Ejiofor, Nicole Gioia Massa, and Michael Johansson. And again, I'm going to let them introduce themselves. Tell you guys a little bit more about what they're working on right now. And so I'm going to start off with Dave here. If you could land, let me ask you a question. If you could land on one place on Mars, where would that be and why?
If I could pick just one place, I actually would go back to the Mars Pathfinder landing site for a couple of different reasons. Actually, one of the roles I had in working with the film is I was one of the NASA consultants on the group. And one of the things that I contributed was a lot of knowledge about Mars Pathfinder, as the filmmakers were trying to actually display what that rover was like, what that spacecraft was like. I was able to pull out actually a lot of drawings and photographs because Mars Pathfinder was the first Mars mission that I ever worked on in my NASA career. And so I have a lot of connection with that one. I'd like to go back and find out whatever happened to our rover. One of the things that is touched on very quickly in the book, but you don't really get too much out of it in the movie, is the fact that if you really ask us carefully, we actually don't know precisely where the rover is. The way Mars Pathfinder worked is we communicated through the lander to the rover. The lander died first. We lost the communication pathway. The rover was then programmed, if it lost communication with Earth, to have a couple of behaviors that allowed it to continue to operate. We don't know how long it lasted or where it ended up when it finally gave out. I would like to go back to the Mars Pathfinder site and find my rover someday.
All right, Chiwetel, in the movie you play Vincent Ejiofor, who has a very pivotal role. Can you tell us a little bit about how you prepped for that? How did you get ready to play a NASA official?
Well, there was a few different things and a few different approaches to it. You know, the first thing was, of course, a conversation with Ridley, which the first conversation we had was talking about the film in very broad terms and talking about the character in very broad terms, and then it was book and then the screenplay, and Wikipedia open all the time, just trying to cross-reference everything and learn as much as I could about it. You know, it was a completely new world for me, and literally, and I was very excited in that process. And then I got a chance. I mean, we shot the film actually in Budapest, so I got a chance to speak to people from mainly from the European Space Agency, and at that time they were just landing on the comet that they successfully landed on. So I got a kind of first-hand look at just the excitement, the sort of the project leadership that was happening there, and obviously the stress, and the complications of the kind of work. And so it was a combination of those things that kind of allowed me to get an insight into the sort of the kind of mindset of the agency, and so that was a very exciting part of learning about it all.
Fantastic, thank you. Nicole, I'm actually going to ask you the same questions I asked Dave, but from a totally different perspective. As an astronaut, if you could land one place on Mars, where would it be?
Wow. I think I would want to land wherever Dave or Dr. Green tell me to. And you know, quite honestly, as astronauts, we're kind of the implementers of the experts. The scientists are our managers' mission. And you know, and that's a really wonderful thing, to not have to, you know, have to be that expert as well. And NASA does a really good job of training us for, you know, what we need to know about the science or the systems or where we're going and that kind of thing. And I think the way they do that then allows us, like what's shown in this movie, to improvise if we need to react in almost a predictable way as a crew, to, you know, kind of rally in a calm, directed way to address problems that come up. And you can pretty much guarantee that probably no day or activity will go exactly as it was planned. And even on the space station, although we have pretty much continuous ability to communicate now, there are times where we just don't have comm with the control center, or the issue that's happening takes that comm away from us. So you still have to kind of be on your toes, or float on your toes, I guess, and be able to think quickly and work as a crew in a way that you would expect each other to respond. And I love in this movie how, I mean, I won't spoil anything, but the excitement kind of kicks off with the crew doing exactly that. You know, it's hitting the fan, and they respond in a very, I don't want to say emotionless way, but the kind of way you would need to deal with each other and to be successful. So yeah, I'll go where Dave and Dr. Green tell.
All right, Gioia, tell us a little bit more about growing food in space.
Sure. I think it's very important, and I'll kind of tell you a little bit of a story as to why. So imagine that you're on the longest plane ride or car ride that you've ever been on. And it's really boring. And you're in this cramped space and you can't go outside, and you're eating food that's, you know, maybe not home cooked. Imagine that 100-fold, okay? Not just one day of a really long trip, but 100 days or longer. And then when you get there, you're on this place that's extreme and dangerous and alien and kind of scary and beautiful and exciting, but it's not home. Okay, and the trip back is going to be maybe the same length as the trip out, but it'll probably feel even longer. So think of the things that you miss, you know, the sights, the smells. You'll miss your family and friends, obviously, the tastes of home. Imagine that whole scenario if you had a garden. And think about what that garden might mean to you for this trip. Something to anticipate, to mark changes in the passage of time, something to care for, and something to really get excited about. You know, that first salad that you're able to harvest that you grew yourself, that wonderful flavor and texture of a strawberry that you grew. So I think that that's really critical, and a lot of other people do too. And so that's why, you know, I'm working to help enable gardens for Mars.
Excellent. Michael, you're researching dust mitigation technology, which sounds kind of awesome. We learned from Andy Weir earlier, he admitted that the Martian dust storm was a little bit of dramatic license. Wouldn't have happened exactly like that. Maybe we can get Dave to talk about that more later, but dust is a problem for humans on Mars. So tell us a little bit about how you're working on that.
Sure, so I assume that the creative license that you're talking about is at the very beginning of the movie, there's this dust storm, and it sets off the whole story of the Martian. The thing that we have to remember is that the Mars atmosphere is actually very thin. It's about 1/100th of the atmosphere that we have here on Earth. And so as a result, even though we might have very high velocity, the force that we experience might not be much more than what we would experience here as a breeze on Earth. But it doesn't mean that dust storms aren't an issue. And dust storms are an issue because we have dust in dust storms. And if you look at any of our exploration missions, whether it be Apollo or the the more recent missions to Mars, what you'll see is that dust has always played a role in the design and the implementation of the vehicles. If you look at the Apollo missions, you'll notice that their spacesuits are completely covered in dust. And they weren't really used that much. And when you compare that to the amount of time that we'll use them for future exploration missions, there's some things that we need to work out. If you look at the Mars exploration rovers, you'll notice that their solar panels are covered with dust. If you look at the Curiosity rover, you'll notice that what used to be pristine white is now a rustish color. And so NASA is currently developing technologies that will eliminate or at least significantly limit the effects of dust on the Martian surface. Whether that be actually on surfaces or even through in situ resource utilization plans. So also the Mars atmosphere is very dusty, and we have ways to remove dust from the atmosphere before we send them into the chemical processing plants that you heard about in the previous talk. So the bottom line is, yeah, dust is an issue, and we're working on a way to solve that problem.
Great. All right, we have our students, our DLN students online again, so let's go to one of our questions on the DLN.
Hi, this is Lauren Flanagan. The 8th grade students from Douglas Middle School in Douglas, Massachusetts want to know what technology or advancements are necessary for humans to live on Mars?
That's a great question. Who would like to start with that?
I'll take an initial whack at it. The real answer to your question is all of them. Right now, we have a basic idea of what technologies, we have experience with what technologies it takes to get rovers and robotic systems to Mars. We're actually at the point we're getting kind of good at that, fortunately. But the leap that it takes in terms of technology development and engineering to move from robotic systems where we may be landing on the order of 1 metric ton at a time down on the surface to human systems getting to the surface of Mars where all of a sudden we're landing more than an order of magnitude more, perhaps even close to 2 orders of magnitude more mass on the surface. And so none of the systems that we have right now to get that much mass to Mars, get it down to the surface safely, they don't exist right now. We're working on them, we're developing them, but we've not been able to actually use them yet. We're continuing to develop that system. Likewise, the systems that a human would need to actually survive on the surface, life support, is something that we haven't yet developed as under creation right now. But perhaps most important to anyone who would actually be on that crew, the systems for returning from Mars, actually blasting off from the surface, getting up to Mars orbit, and getting from Mars orbit back to Earth orbit, those systems have not yet been developed and tested and validated. So all of those, along with many, many other subordinate technologies, radiation protection, nutrition analysis, and tools for maintaining crew health and spacecraft health. All of those sort of things are all in development right now, and we need all of them. And basically, we need a whole bunch of really good, really smart people who understand how to tackle these problems. And this is why I'm looking at all the students that are in the room right now, as well as all the ones that are out there. I said, I would love to go to Mars and find my Pathfinder rover someday. Well, that's not going to happen without a whole bunch of people making that sort of journey possible. And that's where we need all of you guys.
How significant then is the water issue now the discovery of water?
So the water issue is really a fascinating question because we've known for a long time that there was water on Mars. It's in the frozen up in the polar caps of the planet. We actually can see the polar caps expanding and receding with the seasons, and we knew that it was part water ice and part frozen carbon dioxide. The thing that's been a real surprise recently, and not just with Monday's announcement, but even just going back the past few years, is finding out how extensive the potential reservoirs of water may be on Mars today. We've had measurements and observations from various different Mars orbiters, and primarily the Mars Express spacecraft, the European Space Agency, that have given us indications of large reservoirs of frozen water subsurface, relatively near the surface, a few meters down. Volumes of water that were perhaps several times the volume of the Great Lakes. And that was very exciting. But that was sort of what we thought might be a frozen matrix of basically mud. But what we just announced on Monday is not just the possibility of frozen water subsurface, but active liquid water at and near the surface of Mars that is basically very accessible. So as soon as you get to that point, the idea of water being accessible at the surface and being able to be utilized by a human crew becomes a game changer in terms of how we get to Mars. We no longer have to worry about taking all the water we need to survive with us. Instead, we can basically farm water that's there, process it, use it obviously for drinking water for the people, but you can also use it and crack it, break it down to provide the oxygen to breathe, but also then combine it with hydrogen and oxygen and other forms to create the rocket fuel you need for a return trip. So it really changes a whole scenario, the whole architecture for how we get to Mars and get people back. So that's a very big deal.
Don't forget watering your plants too.
Absolutely.
Well, I thought it was so cool too, Dr. Green talked about it a little bit, just the nutrients and the components of the soil that we're finding now that can benefit what you want to do as well.
Yeah, this whole area of in situ resource utilization, ISRU, that we keep talking about. I mean, the more that we can use on Mars, the less we have to take with us. You know, and that's one of the other benefits of potentially growing plants. Seeds are a lot lighter to take than food. So if you can recycle things, recycle the inedible plant waste, the human waste, all of these things are no longer waste. They're resources. And if we have resources available on Mars as well, then we're farther along than we would be if we had to take everything with us. So using any of those resources is going to be really, really valuable because it costs a lot to launch even a small amount of material to Mars.
All right, let's take a question from one of our students here in the room. And for those that didn't hear that question, it was about astronauts. Do astronauts do mental training and other kind of preparation to be away from home for so long?
Okay. Yes, we do. In fact, part of the selection process involves that as well. Some psychological exams that you take, both written and interviews that go on. So they're looking at in the whole selection process. How they really psych that out, I'm not quite sure, but seems to work. And then it's interesting, I would say the bulk of our training outside of learning about the systems and the scientific aspects of the payloads and research that are going on is really team building, what we call expeditionary type training. And that can be everything from going and living for a couple weeks underwater in a habitat that's similar to what you would experience in space, on a space station or on the surface of a planet somewhere, to hiking in the canyonlands of Utah for 10 days with just the 6 people in your crew and not seeing anybody for that entire time. And a big part of that is you learn how you work together as a crew, but you also learn a lot about yourself. This kind of self-awareness that I think you really have to have in order to understand what your own strengths and weaknesses are, what those of your crew are, so that you can work best as a team. And then when you're on your own, I can tell you, when you're out on a spacewalk and you're in your own little spaceship crawling around the space station, you have to understand those kinds of things about yourself and how you're going to deal with something if things don't go as planned. And I think we do a really good job of kind of subtly even incorporating that into the bulk of our training. And I know now there's a lot of studies going on where we're polling ourselves with questions from our behavioral science folks on, if you're on this kind of class of mission, going this long, this far, based on your experience on the space station or on the space shuttle, what do you think, you would need? Those kinds of things like, growing fresh food, having plants around you, visual references that you lose if you go farther from Earth. those kinds of things. How do you supplement it? How do you communicate with your family and friends? And it's a big deal. And it's really neat to see kind of the evolution of how we develop plans for incorporating those things into a mission.
Okay, let's go to one of our questions from the DLN.
Hi, on behalf of the students at Atlantic Technical High School, we want to know, what do we hope to gain from our explorations to Mars? Tell us first.
All right, so what do we hope to gain from our exploration of Mars?
I think probably the thing that we hope to gain the most is the thing that we don't know how to ask about, if that makes any sense. It's the stuff that we don't know is there that is probably going to be the most amazing, the most valuable, the most interesting that we're going to find out about Mars. Jim Green talked earlier about the idea that having Mars as the beginning of Earth 2.0 as our ability to back up the species is a huge thing. But in addition to that, we're going to discover stuff when we get to Mars, things that the robotic systems may not have been able to tell us yet, that are going to surprise us, and we'll sort of sit there and go, how did we not see this coming? But of course, those are all great, wonderful discoveries. And so I think those are the ones that will be most valuable, most interesting to us.
Yeah, and I think we can't discount all of the things that we'll discover along the way as we learn to live to get to Mars. I mean, a lot of the things that we've developed now to learn to live in low Earth orbit have had a lot of Earth-based benefits as well. And I think that's just going to be accelerated as we proceed towards Mars. So all of these things will impact everyone on Earth. And to talk to Dr. Green's point earlier about backup planet for humanity, you can also think of it as a backup planet for all life on Earth. We're the only species on this planet that's spacefaring at the moment. But life on Earth has evolved and is complex and is wonderful. And so we're kind of everybody else's only hope as well, all the animals and plants and everything. So think of it that way as well. It's pretty important stuff.
I will modify that just one little bit, just point out that right now, to the best of our knowledge, Mars is currently the only planet in the universe populated solely by robots.
All right, we have another DLN question, so let's go to a question on the DLN.
Hi, we're from Grimsley High School in North Carolina, and our question is, I read that on the trip to Mars, the spaceship would be subjected to lots of radiation, which is a lot more than normal, and we were wondering, how would you combat that?
That sounds like something a lot of the crew would have high interest in. One of the things that we are working on now in the various Mars and spacecraft technology programs is radiation protection systems. Okay, throw a couple numbers at you. One of the things we've done in our analysis and using some of the measurements from Curiosity rover and other spacecraft is been to look at the radiation levels that the spacecraft is exposed to both during the cruise from Earth to Mars as well as down on the Mars surface. And using those measurements, we've been able to determine that for what we estimate would be a typical 500-day mission from Earth to Mars, Mars surface, and back to Earth, you would get a total body dose of just over 1.01 sieverts of radiation. And that's considerably higher than the typical level that you would get as a human existing on Earth under the protection of the Earth atmosphere and the Earth magnetosphere. What that translates into is an estimated lifetime probability of about an increase of about 5% of contracting fatal cancer. So that's a fairly significant increase in radiation dose that the astronauts will be exposed to. To counteract that, we are looking at a lot of different technologies for how to protect the humans, both during that transit from Earth to Mars, and back to Earth, which actually is when most of it is absorbed, as well as down on the Mars surface itself. And there are all sorts of different shielding technologies that we're taking a look at, as well as ultimately in the long term, seeing if there might be things that we could do to the astronauts themselves, the human body, to be able to better contend with absorbed radiation for things that we can't shield from. We don't have the ultimate answer yet. We're working on it right now, but it very definitely is one of the topics of interest.
All right, let's go to a question here in the room. We've got a question right here.
How would we extract the water from polar ice caps?
I'll answer.
Yeah, but in the movie, you know.
We showed it a while ago. I could have told you that at least.
Basically, what you're looking at is just sort of the ultimate instantiation of a big water purification system. So one of the things that, with the recent announcement on Monday of actually having potentially liquid water added near the surface all over the planet, not just the poles. One of the things that does is tell us that it's much more accessible, which means we don't actually have to go to the poles just to get to the water resources, but we can actually tap into stuff that's near the surface in equatorial regions. But what you've got there, and what we are describing as water, is basically a thick, extremely salty brine, but you then got to go through a process of purifying that. But there are all sorts of different processes. You can use, if it's sort of frozen mud, first thing you do is you melt it, you get the liquid. From that, you can then distill it, purify it, filtration processes, things like this. So those techniques are actually pretty well understood for being able to extract the water. Or if you really wanted to get sort of sporty about things, again, if you watch the movie or you read the book, there is a fairly dramatic chemical process that can take place if you're willing to insert enough energy and control how it's extracted to convert oxygen and hydrazine into drinkable water. It's not a recommended practice, but it does work.
All right, let's go to a question from social media.
So hi, this is a question, so I have two ones very quick for Nicole. This is from Emily Martinez, although several other people want to know. Do NASA astronauts really bring duct tape to space?
Yes.
Do you have any fun uses they used for it?
Yeah, it is one of the staples up there for all kinds of things. And I think it kind of speaks to this philosophy of, keeping it simple. I think there's a lot of places where we can think about very complex ways to do things, and the simplest way is usually the better way. And duct tape is one of those really brilliant examples of that. Yeah.
And this is from Dr. Holland, who is he's one of our DLN, it's from Lincoln Junior High. He's one of the teachers. This is to Chiwetel. What was the most difficult part about making the movie realistic, at least on your end?
I didn't think it was hard. A lot of the work had been done before, in terms of, obviously, Andy Weir's, brilliant book, Drew Goddard's great script. And so, I think that what they were able to do is really combine these ideas of science fiction and science facts. So it almost felt seamless, Like I was saying before, a lot of time I spent just with the Wikipedia page open and cross-referencing things and, really trying to understand what the science fiction parts were, and then being able to look at the location, for example, of Pathfinder and its capabilities and see what the differences were with the Pathfinder that we had and the one that's actually up there, And it's so that was a very exciting, just understanding the depth of research that had been taken already. So I was sort of thrilled to come on board with something, especially with Ridley Scott, who has such an in-depth sort of understanding and is able to combine that with this really sort of extraordinary creative imagination. So a lot of that was already prepared, so you could just kind of concentrate on acting, which was great.
And you said a little bit earlier, well, I'm just an actor, kind of thing. But I would like to say that, I've been on, I think it's been 2 days now of this trip, going along with the movie and sharing both kind of the science side and the movie side of this whole thing. And I just want to say thank you because, from Ridley Scott to Andy and the folks who put together the story, it has been really impressive to me to spend time with, Sebastian the last 2 days and Mackenzie and now meeting you And to see I think really the deep down heartfelt enthusiasm for what the basis of the story is, and to allow us, and I say us as NASA, to communicate to audiences that might not ever think about space in their day-to-day, routine. And I think we need to do more of that. We need to do more, presenting of the real kind, the science fact stuff mixed with, really interesting stories to engage the public and to help them recognize the wonderful things we're doing in space right now on the station with our robotic exploration and what we have to look forward to in, this journey to Mars. So thank you very much.
All right, believe it or not, we are almost out of time, so let's go to one last question on the DLN.
I'm Riley from Newcastle, Pennsylvania. My question is, how is it possible for sandstorms to be on Mars with the low atmosphere?
So there's still an atmosphere. It's just thin. So there's still wind that can move around dust, and it's not something that it's enough of what we say is it's enough of an atmosphere that we have to worry about, but not enough that we can do a whole lot with. Besides the chemical processing type thing. So similar to how we can kick up dust here on Earth, we can also kick up dust in the Martian atmosphere.
How does the dust compare between Earth dust and Mars dust?
So there are some differences. For one, I'm told by the medical team and also by some chemists that it's a bit toxic, so you probably don't want to be around it, which is another one of the reasons why dust mitigation technology is so important. When we look at other places, so if we look at, for example, the moon, they're jagged particles because we don't have an atmosphere to kick around the dust and smooth the particles. And there's some of that on Mars as well. So there's different mechanics, there's different chemical makeup, and we're left to figure out what to do with it. How do we exploit it for our exploration purposes and keep away from the nasty part of it?
Is the wind helpful for energy production? Is it enough?
Maybe if it was, maybe if it was the right system, but it's a pretty thin atmosphere.
All right, I just want to say thank you to our awesome panel up here, and thank you to all of our speakers today, and to all of you and all of our students on the DLN and everyone who watched us on NASA TV for participating and sending in your questions today. And I hope you'll continue to follow along with NASA, and remember you can learn more about NASA's work on the journey to Mars by visiting www.nasa.gov. Thanks, everyone.
I saw somebody booked thanks. It was actually my sister's question. She wanted to ask, but she was in school. So.